Everyone talks about ChatGPT and GPT-4, but did you know that there are open source models that can outperform these giants? Today, we are diving into a showdown between two powerful open source models, Meta's LLaMA and the rising star DeepSeek. Welcome to AI Club Pro, where we make AI concepts feel like everyday ideas. In this video, we'll dive deep into the exciting open source battle, breaking down how LLaMA and DeepSeek stack up head to head. We are going to cover the incredible journey of Meta's LLaMA family and the rapid rise of DeepSeek, which is a new challenger, and finally, a clear, structured comparison to help you decide which model will suit your needs the best. A quick note before we dive in. Both models provide open source weights under special licenses, allowing developers to download, deploy, and fine-tune them directly. Unlike proprietary models from companies like OpenAI, which you typically access via paid APIs, LLaMA and DeepSeek models let you have full control. However, deploying these massive models isn't free. You'll need specialized hardware, often rented from cloud providers. If you're new to terms like model weights or fine-tuning, check out our videos on what is an AI model and fine-tuning versus RAG for more details. So let's get started with the LLaMA family of models first. Meta first launched LLaMA, which is short for Large Language Model Meta AI, in February 2023. The LLaMA model was built on the basic transformer decoder architecture with a few key modifications in normalization and positional encoding vectors. The first LLaMA model supported a context window of 2048 tokens. Initial releases included a 7 billion, 13 billion, 33 billion, and 65 billion parameter variants. The LLaMA model was built on the basic transformer decoder architecture with a few key modifications. These modifications were in normalization and the positional encoding vectors. The first LLaMA model supported a context window of 2048 tokens. Initial releases included 7 billion, 13 billion, 33 billion, and 65 billion parameter variants. Although powerful, LLaMA required fine-tuning or careful prompting for specific tasks. It was not instruct-tuned, which means it cannot answer chat questions like a ChatGPT does. The largest variant, which is the 65 billion parameter version, achieved approximately 63% on the MMLU benchmark. In July 2023, an improved version called LLaMA 2 was released with an expanded 70 billion parameter model, which replaced the previous 65 billion parameter model. LLaMA 2 also included models fine-tuned for dialogue, which are chat versions. This model was trained on 2 trillion tokens of data, including a mix of publicly available text, code, knowledge, conversations, etc. And the result was a significant jump in capability. The 70 billion version of the model achieved around 69% accuracy on MMLU under standard evaluation, which was pretty close to the score of GPT 3.5 at that time. It also nearly doubled LLaMA 1's performance on coding tasks, which is represented by HumanEval and math benchmarks from 38 to 67. In April 2024, LLaMA 3 was released in the 8 billion and 70 billion parameter sizes. It offered instruction-tuned models as well. By July 2024, LLaMA 3.1 extended the model with up to 405 billion parameters and dramatically increased the context window to 128,000 tokens. Later that year, around September, LLaMA 3.2 introduced multimodal capabilities processing both text and images in its initial open source releases. Rounding out the year, LLaMA 3.3 re-optimized the 70 billion variant for efficiency and cost, so it delivered a similar performance but with a reduced demand on resources. The latest evolution is LLaMA 4, which arrived in April 2025. It featured a mixture of experts architecture. Its Scout variant has 17 billion active parameters during inference and a 10 million context window size. The Maverick variant also has 17 million active parameters with a 1 million context window. And there is an upcoming model called Behemoth, and this variant might have up to 2 trillion model parameters. LLaMA 4 emphasizes multimodal and multilingual enhancements. So that's a summary of the timeline and the performance of the LLaMA models. Let's now talk about DeepSeek. So DeepSeek stormed into the AI scene in early 2024, where it debuted with a 7 million and a 67 billion parameter model, which was trained on a massive bilingual English and Chinese dataset. So it really stood out and excelled at both languages, which was a strategic edge against competitors. Soon after, the DeepSeek chat models arrived, which were fine tuned specifically for conversation tasks. And the standout performer, DeepSeek 67 billion chat, stunned the community with extraordinary scores, with around 74% in coding challenges and 84% on math tests, easily surpassing the established open source models like LLaMA 2 at that time. But then DeepSeek had another release called DeepSeek V3, where they had a mixture of experts architecture, and as a result of that, the number of parameters ballooned to 671 billion. However, the active parameters were only 37 billion per query for efficiency. It also had a large context window size of 128,000 tokens. And then came DeepSeek R1 in 2025, which was specially trained with reinforcement learning methods for complex reasoning tasks. Third party tests on DeepSeek R1 showed that it in some cases surpasses models from OpenAI and Anthropic on tough benchmarks, particularly in coding and math. And perhaps most impressively, the DeepSeek team successfully distilled advanced reasoning capabilities into significantly smaller and more efficient open source models. They achieved this by transferring knowledge from the R1 model into the compact variants built on popular frameworks like Meta's LLaMA and Alibaba's Qwen. These smaller models, despite their reduced size, demonstrated a pretty good competitive performance and in some tasks even surpassed OpenAI's GPT-4, particularly in specialized domains like mathematics and software coding. This type of innovative distillation not only makes cutting edge AI more accessible and affordable, but also highlights how quickly the distinction between open source and premium AI assistance is narrowing, democratizing it for a wider audience. In terms of architecture, DeepSeek's architecture closely mirrored LLaMA's transformer decoder structure. However, DeepSeek later evolved significantly by adapting a mixture of experts design, allowing it to massively scale parameters while keeping inference efficient, unlike LLaMA's dense model structure. So that's a summary of the releases from DeepSeek and its performance. Let's now introduce a clear framework to compare these two open source models. We'll evaluate their latest versions across 5 key criteria: context window size, coding and math performance, general knowledge, community and ecosystem, and the deployment efficiency and speed. Starting with context window size, LLaMA 4's Scout variant supports an impressive 10 million tokens, while Maverick handles about 1 million tokens. DeepSeek R1, however, offers a highly practical and optimized version of 128,000 tokens, which is ideal for typical long documents, making this category effectively a tie, as LLaMA excels in sheer scale while DeepSeek R1 shines in everyday scenarios. In coding and math performance, DeepSeek R1 takes a clear edge, achieving approximately 73.3% on HumanEval for coding and about 84.1% on GSM-8K tasks, compared to LLaMA's estimated 70 to 80% performance. Similarly, in general knowledge benchmarks, DeepSeek R1 holds a distinct advantage with scores of 93.4% on MMLU Redux and 85% on MMLU Pro, surpassing LLaMA 4 Maverick's 80.5% accuracy. LLaMA 4 benefits from an extensive and established community ecosystem, whereas DeepSeek R1, while rapidly growing, is still developing, giving LLaMA the upper hand here. Lastly, deployment and speed considerations result in another tie. LLaMA 4's dense variants offer simpler, efficient deployment on smaller scales, while DeepSeek R1's mixture of experts architecture achieves higher efficiency at massive scales but demands more complex hardware management. This rivalry isn't just academic, it represents a shift towards democratizing AI innovation. DeepSeek's remarkable performance at a fraction of the usual cost proves that open models can rapidly close gaps and even surpass the proprietary giants. It also highlights a critical turning point where AI could become widely accessible, customizable, and affordable for more researchers and developers worldwide. So, who wins? Right now, DeepSeek is likely ahead, particularly in cutting edge tasks. But the real winners here are us, the community, the developers, the users. With each leap in open source innovation, everyone gains access to better, more powerful AI. So, who will lead next year's AI revolution? Well, we have to keep watching the space because today's challenger may become tomorrow's champion. Thanks for joining us on AI Club Pro, and hit that subscribe button for more eye opening AI stories and insights. Until next time, stay curious and keep exploring.